Welcome to this video in which we will have a look at Yest, Smart Testing's visual test design tool that helps creating better tests 40% faster. Yest is a desktop application running on Windows. It allows you to visualize complex behavior of various systems under test and to share this visualization, for example, in Jira. In this video, we want to show how Yest can be used to create Python test scripts from a state diagram-like model. The system we are testing is a wind turbine. In our example, three main factors influence the status of the turbine: the wind strength, the distance to flocks of birds, and interruptions due to repair and maintenance. The states of the turbine can best be described with a state diagram. There are four states called off, ready, on, and need repair. Only if the turbine is in state on, the blades rotate. For this to be the case, the wind must be between 15 and 90 kilometers per hour, and flocks of birds must fly past at least 500 meters away. And the turbine must, of course, be functional. Let's have a look at Yest. As this is a test model, the state diagram looks slightly different. Between the states of the turbine, we find further actions in which we defined what is to be tested. They correspond to the transitions, but allow us to introduce testing aspects without the model becoming unreadable. Here, to the bottom left of Yest, you see the data browser, in which we define the equivalence partitions for the parameters that guide the test. The wind can be too weak, too strong, or just right. The birds are either sufficiently far away, too close, or not present at all, which is, of course, also good for the turbine. An error may or may not be detected. Depending on the values of these input parameters, the turbine will be in one of the states I mentioned previously, and the blades are rotating or not. These values are used in the test actions, for example, when we reduce the wind speed below the limit. If you have a closer look at the model, you will discover that there are only 7 different actions because we always use the same function to set the wind speed. The same is true for the bird's distance and for the 4 status checks. By default, Yest generates 6 test scenarios. This is the minimum number required to cover all equivalence partitions. In this example, the turbine is first off, then ready. When we set the wind speed and the bird's distance to fair conditions, it switches to status on until the wind becomes too strong. Even worse, we cause a failure which is then repaired. But wait, there's an error in this scenario. We only have one turbine, but it says turbines are off. Let's fix that before we proceed. Have you seen that? Not only does Yest give me the option of jumping directly from the generated scenario back to the editor, the change is also automatically propagated to all instances. But back to the topic. We wanted to take a look at how Yest generates Python test scripts. Yest interfaces with Python through the Python publisher. In the publisher, I have to map the test steps to keywords in Python. The keywords are defined here. As you can see, the keywords may take parameters and implement asserts. The mapping is done once for all instances of the table row, so let me map the last missing keyword. Miracle! All test scripts are repaired. This is the generated Python code. When I press Publish, the scripts are written into the target directory of our test automation framework, in which they are executed as usual. Have you noticed how helpful Yest has been? With Yest, even non-programmers can contribute to test automation and help overcome the bottleneck. Yest also offers many other functions that make it easier to create and revise tests, but that's another story. Just send us an email. We'll be happy to show you why we call Yest the tester's IDE.